In our last class, we are discussing the combination of lenses, combination of thin lenses, where we got the final focal length or the effective focal length as 1 by f equal to 1 by f1 plus 1 by f2. In terms of power, the power of the combination of the lenses will be P is equal to P1 plus P2 plus P3 and so on if there are n number of lenses. Okay, today the next point, the refraction through prism. Refraction through prism. Okay, so this is the prism, and prism consists of two refracting surfaces, inclined at a particular angle, and there will be a base, and the angle between the two refracting surfaces is called angle of prism, and usually it is represented by symbol A. A is angle of prism. Okay, so I'll give the name for this prism as ABC. Okay, so here there will be a refracting surface and here one more refracting surface. So they made an angle A. Okay, and this is the base. Is it? Okay, whenever a ray of light incident on a prism like this, a ray of light incident on a prism, then so there is a normal line. This is normal line. Okay, so whenever a ray of light incident on a surface of the prism, the surface AB surface of prism. Okay, so if there is no any effect or if there is no any influence of the prism on the ray, then a ray has to pass in this direction, has to propagate in this direction. But is it possible? Is it possible to move a ray through a prism like this? No. And we know, so this is one type medium and this is another type of medium. So usually the prism is made up of glass, and we may use the different type of glasses on the basis of the medium which we use. So the refractive index depends. Okay, here this is air medium or vacuum is having a particular refractive index, and the ray of light incidenting on an interface of glass and air medium. As a result, there must be a phenomenon. What's that phenomenon? It's nothing but the refraction. As a result of refraction, instead of moving in this direction, it bends towards the normal line. Why does it bend towards the normal line? Because it is rarer medium, it is denser medium. So while it is moving from rarer to denser, so it has to bend towards the normal line. So this is the refracted light. Okay, and for this I call it angle of incidence. This is angle of incidence. Okay, and what call for this one? Angle of refraction. I call this is R1. Angle of refraction R1. And see the refracted ray of the first surface. The refracted ray of first surface become the incident ray for the second surface. Okay, I'll draw one more normal line here. So this is the normal line. Okay, this is a normal line for the second surface at the point of incidence. Okay, and see now the ray of light is moving from glass to air medium, denser to rarer. So now it has to bend away from the normal line. Okay, as a result, instead of moving in this direction, instead of moving in this straight direction, it bends and it travels in this direction. Okay, so for this ray we call it incident ray. This is incident ray, and this is emergent ray. This is emergent ray, and the light which is inside that prism we call it is a refracted ray. Incident ray, refracted ray, and emergent ray. And for this angle of the angle made by the emergent ray with the normal line, this is called angle of emergent or emergent angle. And this is the incident angle for the second surface. Incident angle for second surface, and we represent it by R2. This is R1 and this is R2. R1 is refracted angle of refraction for first surface. R2 is angle of incident for the second surface AC. Is it clear? Okay, so angle of prism, angle of incidence, and angle of emergence. Okay, these 3 points are very important. Then see here, if I extended the emergent ray backward, if I extended the emergent ray backward, so it seems like this. Okay, so see if there is no any refraction by the prism, the light has to be in this direction. But because of the refraction, instead of in this direction, it is moving in this direction. Okay, and I say this is deviated. The ray of light is deviated from in this direction to in this direction. So from here to here, the light is deviated. So how much it is deviated? We can calculate it. So we can calculate it by the angle. I can say this is deviated through a particular angle, and that is delta. For example, it may be 10 degree, 20 degree, 30, 40 degree like this. So actually this is the original path of light. Okay, it's the original path of incident light. But when it is coming out of the prism, it is in this direction. So how much it is, and we can say it is deviated. It is deflected or deviated. How much it is deviated? So we can measure it by extending it backward, by extending the incident ray forward. Okay, what is this? This is the direction of incident ray. This is direction of incident ray, and this is direction of emergent ray. And the angle between these two is the angle of deviation. Very important term. And the symbol is delta. So you should pronounce it as delta. Okay, so delta is angle of deviation. Angle of deviation. Okay, what is the angle of deviation? It is the angle between direction of incident ray and the direction of emergent ray. Be careful, it is not an angle between incident ray and emergent ray. It is the angle between direction of incident ray and direction of emergent ray. If you say only the angle between incident ray and emergent ray, so this is the incident ray. Okay, we should say it's the direction of incident ray and it's the direction of emergent ray. And the angle between these two, this is delta, which is angle of deviation. Okay, the light is deviated at this angle. Is it clear? Okay, and see here, as angle of incident changes, the angle of refraction for the first surface changes. Okay, as the angle of refraction changed, the angle of incident for the second surface changes. As this changes, the emergent ray changes. Is it clear? So the emergent angle, as the emergent angle changes, the deviation changes. For example, the emergent ray is here. Now we can say this is the angle between incident ray direction, emergent ray direction. This is delta. If it is here, the angle of deviation increases. If it is here, the angle of deviation further increases. So like this. So the angle of deviation, it is depending on the angle of incidence. The angle of deviation depends on the angle of incidence. So how do you say? So as the angle of I changes, R1 changes. As R1 changes, R2 changes. As R2 changes, E changes. As the E changes, so this angle changes. This is nothing but angle of deviation. Okay, if anybody asks you on what factor the angle of deviation depends, so it not only depends on the angle of incidence, it also depends on the area of prism and the surrounding. Is it? So angle of deviation depending on the area of the material of prism and area of surrounding, and then angle of incidence. But the area of prism and area of surrounding, it is constant. It is constant. Once you manufacture the prism, it will be constant forever. And we can change the angle of incidence at any time. So as you change the incident, the deviation changes. Okay. And if you have an experiment with the prism, by changing the angle of incidence and by noting the angle of deviations, so we will get a important result. We'll discuss it. Okay, I'll take up two columns. So one is angle of incidence and another is what? Angle of deviation delta. Angle of deviation delta. Okay, first I allow the light to incident on the first surface. So I allow the light to incident on the first surface at an angle 10 degree. At an angle 10 degree. So as a result, I get something emergent angle. So I can measure the deviation. Okay, I measure it as for example, I measure it as 60 degree. So when I incident ray is 10, the angle of deviation was 60. So how we got angle of deviation? I measured direction of incident, direction of emergent, and I measured this angle. It was 60. Okay. Then I increased to 20 degrees Celsius. I increased to 20 degrees Celsius, and this become 50. Okay. Then what happened here? As I am changing the angle of incidence, the angle of deviation is also changing. And as we increase the incidence, the angle of deviation decreasing. Okay, I increase to 30. Okay, and this become 55 degree. Right, and I increase it for 39. I increase to 39, and this become 50. Okay, I increase to 40. I increase to 40, and this become 49. Okay, and I increase to 41. I increase to 41. What is the 41? Angle of incidence. This become 50. I increase this to 50. So this become 55. I increase to 60. This become again 59. Like this. Okay. So up to what angle I can increase angle of incidence? ಎಷ್ಟು angle ವರ್ಗ ನಾನು increase ಮಾಡ್ಲಿಕ್ಕೆ ಸಾಧ್ಯದ? ಈ ಡಯಾಗ್ರಾಮ್ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದ? ಇಲ್ಲಿ ನಾನು 10 ಡಿಗ್ರಿ ಮಾಡ್ಕೊಂಡ ಹಿಂಗೆ 10 ಡಿಗ್ರಿ ನೆಕ್ಸ್ಟ್ ಚೇಂಜ್ ಮಾಡ್ದ ಸಾರಿ ಇಲ್ಲಿಂದ ಮೆಷರ್ ಮಾಡಬೇಕಲ್ಲ angle of incidence with respect to the normal line. So ಇಲ್ಲಿಗೆ ಮಾಡಿದ 10 degree, 20 degree, 30, 40, 50, 60 up to what? Up to 90 degree. If the angle of incidence is 90, it will be grazing line. It grazes the surface of that prism. Okay, and see here, as I increase the angle of incidence, the angle of deviation go on decreasing. Okay, so up to what it is decreasing? Up to 49 degree. Up to 49 it was decreasing. Okay, so I increased to 10 to 20, 20, 30, 39 and 40. So as a result, the deviation is decreasing. Angle of deviation is decreasing up to 49. If I increase the angle of incidence further, what happened? The angle of deviation also start to increase. Okay, so if I started the values from 0 to 90 degree, for angle of incidence, so I can get various values for angle of deviation among all the values. So this will be the lowest value. Okay, I call this is a minimum deviation. And check here, this is 60, 50, 55, 50, 49, again 50, 55, 69, like this only. Again they are increasing. So the minimum value is 49. For this we call dm. We call it as capital D subscript m. So what is that dm? It is angle of minimum deviation. This is called angle of minimum deviation. It is a very important one. Angle of minimum deviation. Clear ಬರ್ತದ? Okay, so what's the angle of minimum deviation? So for our example, in our example, 49 degree is the angle of minimum deviation. Angle of minimum deviation is a 49 degree. Is it clear? Okay, if I draw the graph, I versus deviation. Okay, so this is delta. What's the delta? Angle of deviation. And this is angle of incidence. Angle of incidence. Okay, so starting both the axes starts from 0, 0. Is it clear? Okay, and see our column. So I'll draw the graph of these values only. Okay, first it is angle of incidence is 10. So I say this is 10. Okay, at 10 I say this is 90, and this is 70, 80, 70 and 60, 50 and so on like this. Okay, for 10 degrees Celsius deviation was 60, and for 20 means I increase the angle of incidence, and this become 50. Like this, as I increase the angle of incidence, the deviation angle decreasing, so it is like this. Okay, so up to what? Up to 49 degrees Celsius, up to 49 it was decreasing. Okay, when the angle of incidence was 40, it reached the minimum value. Okay, and if I increase the angle of incidence further, so then it starts to increase. Is it? So initially, as we increase angle of incidence, the deviation is decreasing, okay, up to a particular value. So what's that particular value? In our example, it is 49 degree. Symbolically, this is dm. And if you increase the angle of incidence further, so what happens? It starts to increase. The angle of deviation again starts to increase. So for all the values from 0 to 90 degree, so having a single minimum value, that is 49 degree, and this is called a minimum deviation. And here you can observe one more thing. For a given prism, for a given prism, for a given value of deviation, for a single value of deviation, you will have two values of angle of incidence. Have got my idea? Have you got my point? In alpha angle, for a single value of angle of deviation, for a single value of angle of deviation, we will have two values of angle of incidence. What it mean? For example, I need 45 degree. So I need the angle of deviation 45 degree. So where is 45? Here this is 45. Okay. So if 45 angle of deviation ಬರ್ಬೇಕಂದ್ರೆ ನಾವು angle of incidence ಎಷ್ಟು ಇರಬೇಕು? Angle of incidence ಎಷ್ಟಿದ್ರೂ ನಮಗೆ 45 ಡಿಗ್ರಿ ಬರ್ತದ. ಇಲ್ಲಿ ತಗೊಂಡು ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಎಷ್ಟು ಬರ್ತದ? ಇದು 45 ಡಿಗ್ರಿ ಬರ್ತದ. Okay. So to get a particular value of angle of deviation, we will have two values of angle of incidence except the minimum deviation value. But deviation value 49 degree deviation of minimum ಅಲ್ಲ. 49 ನಮಗೆ ಯಾವ ಇನ್ಸಿಡೆನ್ಸ್ ಬರ್ತದ? It is only 40. 49 ಮಾತ್ರ 49 ಬರ್ತದ. But ನಮಗೆ 45 ಬೇಕಾಗಿತ್ತು. Is it our angle of minimum deviation? No. Then it has two values. Okay, for example, I measure this is 32 and I measure this is 46. For 32 angle of incidence, I am having a 45 deviation. For 46 incidence, again I am having a 45 deviation. Is it clear? Okay, it is all about the angle of minimum deviation. Okay, one more thing. See this diagram. And this is the refracted ray inside the prism, incident angle and emergent angle. Suppose we are in a case of minimum deviation. Then experimentally it is found that at the situation of minimum deviation, the angle of incidence is equal to angle of emergence. So it is the experimentally found result. So we did the experiment and we observed the things, and these are the conclusions. What are the conclusions? At the minimum deviation position, at the minimum deviation situation, the angle of incidence is equal to angle of emergence. And also the refracted ray inside the prism is parallel to the base of prism. So these are very important conclusions by this experiment in the situation of angle of minimum deviation. Okay, so ಏನಂದ್ರೆ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಆಗಬೇಕಾದ್ರೆ ನಾವು ಎರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ವಾ? ಯಾವ ಎರಡು ಪಾಯಿಂಟ್? ಸಪೋಸ್ ನಾವು ಪ್ರಿಸಮ್ ಅಲ್ಲಿ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ನಾವು ತಗೊಳತ್ತಿದ್ವಾ, ಆ ಸಿಚುವೇಶನ್ ದಾಗ ಇನ್ಸಿಡೆಂಟ್ ಆಂಗಲ್ ಮತ್ತೆ ಎಮರ್ಜೆಂಟ್ ಆಂಗಲ್ ಎರಡರ ವ್ಯಾಲ್ಯೂ ಏನಿರ್ತಾವ? ಈಕ್ವಲ್ ಇರ್ತಾವ. ಆಮೇಲೆ ಆ ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ ಆ ಸಿಚುವೇಶನ್ ದಾಗ ಈ ಒಳಗಡೆ ಏರಿಯಾದಾಗ ಇದಕ್ಕೆ ಏನಂತ ಹೇಳಿದ್ರೆ ನಾನು ರಿಫ್ರಾಕ್ಟೆಡ್ ರೇ ಇನ್ಸೈಡ್ ದ ಪ್ರಿಸಮ್, ಇಟ್ ಈಸ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಬೇಸ್. Okay, these are the things what I explained here. So as the angle of minimum deviation or the minimum deviation occurs when I equal to E and the refracted ray inside the prism is parallel to the base of prism, and the converse is also true. So ನೀವು reverse ಹೇಳ್ಬೋದು. If angle of incidence and we are observing a refraction through the prism and I got that I is equal to E, angle of incidence equal to angle of emergent ray, and I also observed the refracted ray inside the prism is parallel to the base of prism. If these two are satisfied, if I observe these two, so then I can say the prism is in the case of a minimum deviation. ಗೊತ್ತಾಗ್ತದ? ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂ ಇರಬೇಕು. ಈ ವ್ಯಾಲ್ಯೂ ಇತ್ತು ಡೆಫಿನೆಟ್ಲಿ ಅಲ್ಲಿ ಏನಿರ್ತದ? ಮಿನಿಮಮ್ ಡಿವಿಯೇಷನ್ ಇರ್ತದ. And one more thing, if the refracted ray is parallel to the base of prism, then I can also write one more result. R1 equal to R2 equal to 6. So both are equal. R1 value and R2 value are equal. So these two are very important points. You may get a 2-mark questions. 2-mark question like write the condition for minimum deviation. Or minimum deviation occurs only when I equal to E and the refracted ray inside the prism is parallel to the base of prism. Okay. Okay. The next one is prism formula. Usually it may ask you for 5 marks. So derive the prism formula. Or you may get a question. Derive the relation between, derive an expression that relates the angle of prism, the symbol is capital A, Ri of prism, small n, and angle of minimum deviation dm. So you should establish a relation between A, n, and dm. So it's an important 5 marks question. Okay, so to begin the derivation, you should start with a diagram and explanation and see the diagram. So A, B, C is a prism, face of prism. A, B, C is a face of a prism. Okay, and PQ is incident ray, QR is refracted ray, RS is emergent ray. Okay, you may write this as an incident ray, refracted ray, and emergent ray in your explanation, or you directly start with let I be the angle of incidence. Where is the I? I is the angle of incidence, right? And R1 is the angle of refraction for first surface. Okay, and R2 is the angle of incidence, for the second surface. Next, delta is the angle of deviation. Okay, and dm is the angle of minimum deviation. We will achieve it later. Next, A is the angle of prism. So this is the explanation for this derivation. Okay, and the next thing. So I want to get a relation between n, A, and dm. Okay, now consider quadrilateral. Its name is A, Q, N, R. See here, A, Q, N, R is a quadrilateral. Howda? 4 sides iroದಕ್ಕೆ quadrilateral ಅಂತಾರ. 4 ಸೈಡ್ ಇರಬೇಕಾ? So A, Q, N, R. I'll write again. A, Q, N, R. How's this? Okay, it is like this. Okay, actually this is the side of prism. These are the sides of prism. Okay, this is A point, this is Q, this is N and R. And see the diagram. So what it did? So this is a normal line. This is also normal line, and I extended those two. They are intersecting at N. Okay, and this is refracted ray, and I have extended the incident ray. This becomes like this, and I extended the emergent ray backward. So this forms an angle. This is angle of deviation. Is it here? Okay, so E line extend madada, ಇಲ್ಲಿ ಪಾಯಿಂಟ್ ಫಾರ್ಮ್ ಆಯ್ತಾ ಇಂಟರ್ಸೆಕ್ಷನ್. ಆಮೇಲೆ ಇದು ಇನ್ಸಿಡೆಂಟ್ ರೇ ನ ಡೈರೆಕ್ಷನ್ ತೋರಿಸಿದ, ಎಮರ್ಜೆಂಟ್ ರೇ ಡೈರೆಕ್ಷನ್ ತೋರಿಸಿದ, ಇಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಷನ್ ಪಾಯಿಂಟ್ ಸಿಗ್ತಾ. ಇದಕ್ಕೆ ಆಂಗಲ್ ಮೆಷರ್ ಮಾಡಿದ್ವಿ, ಇದಕ್ಕೆ ಆಂಗಲ್ ಆಫ್ ಡಿವಿಯೇಷನ್ ಅಂದ್ಬಿಟ್ವಿ. ಈ ಡಯಾಗ್ರಾಮ್ ನೀವು ಕ್ಲಿಯರ್ ಆಗಿ ತಿಳ್ಕೊಂಡಿರ್ಬೇಕು. ಓಕೆ, ಸೊ ನೌ ಐ ಆಮ್ ಟೇಕಿಂಗ್ ದಿಸ್ ಒನ್, A, Q, N, R, this one. Okay, I draw this one. And we know the sum of all the angles, all the internal angles of a quadrilateral is always 360. So what are those 4 angles here? A, Q, N, R. I'll write angle A, which is angle of prism, and A, Q, N, A, Q, N plus angle N plus N, R, A. So all these angles, so they form 360 degree. Is it right? All of them are equal. All are equal to the sum of all these angles equal to 360 degree. Okay, angle A as it is, and we know the value of AQN. Can you say what's the angle of AQN? AQN. This must be 90 degree. Why is 90 degree? Because see this one. So this is the extended part. Okay, so here you will get the B point. And what is this? This is the normal line. Here it is 90 degree. If it is 90 degree, this must be 90, because this angle is formed by the normal line with that surface. And the same thing, if I extend this one like this, and this is the normal line, and we know this is 90 degree, so this must be 90 here. Okay, I know this to 90 degree, right? I'll write A as it is, and this is 90 degree, AQN, plus I don't know the value of N, plus NRA, so this is also 90, so all equal to 360 degree. Okay, now 90 plus 90, 180. If I take this right hand side, so 360 minus 180, so now A plus N is equal to 180 degree. What I did, I shifted this to 90 this side. Okay, and this 360, then minus 180. So now it is A plus N is equal to 180 degree. I call this is equation number 1. Equation number 1. Is it clear? Okay, next I consider one more triangle that is QNR. Now consider triangle QNR. See the diagram? ಹೆಂಗಿದೆ QNR? So ಇಲ್ಲಿಂದ ಒಂದು ಲೈನ್ ಹಿಂಗೆ ಬಂದಿದೆ. ಯಾವ ಲೈನ್ ಇದೆ? ರಿಫ್ರಾಕ್ಟೆಡ್ ರೇ. ಓಕೆ, ಆಮೇಲೆ ಈ ಡಾಟೆಡ್ ಲೈನ್. ಸೊ ಎರಡು ನಾರ್ಮಲ್ ದಿಂದ ಬಂದಿದ್ವಲ್ಲ, ಅವನ ಎರಡನ್ನ ಇಲ್ಲೇ ಹಿಂಗೆ ಸೇರಿಸಿದ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ Q point, this is R point, and this is N. So we have given name for this angle. What is that? R1. Okay, what is this? This is R2. Is it clear? Okay, R1, R2. Now the sum of all the angles, the sum of all internal angles of a triangle is equal to 180 degree. Okay, so I'll write R1 plus R2, this angle plus N angle. N is equal to 180 degree. 180 degree. So I say this is equation number 2. Equation number 2. Okay, compare equation 1 and 2. Compare equation 1 and 2. You will get an important result. What's that? So see here, in equation 1 you are having the 180 as RHS. Here also 180 as RHS. In the LHS there is N and there is N. What are the remaining terms? Here is only A, but here R1 plus R2. Now can I say this single term is equal to these two terms? Is it right? 180, N, and here it is R1, R2, here A only. So by comparing these two, I can get A is equal to R1 plus R2. So it's a very important result. I call this as equation number 3. Okay. A is equal to R1 plus R2, angle of prism. Is it right? Okay. Then from triangle QER. Where is the QER? Q and the E where the incident direction and emergent direction intersects, and this is R. QER. Okay. If I consider the QER, what is the delta? What do you call for that delta? So I will draw the diagram just like this. This is delta now. Is it? So can I say delta is an external angle? So what's the name? Q, E and R. So this is the external angle from QER. Delta is an external angle. Delta is external angle. If delta is external angle, okay, I want to write the delta in terms of its internal angle. We know the general concept, that is external angle is equal to the sum of opposite internal angles. So delta is equal to this angle plus this angle. Okay, EQR plus QRE. EQR plus QRE. Okay, and how to write EQR value and QRE value. It's very simple. See the diagram. Zoom on. Okay. Here, this is angle of incidence, right? This is angle of incidence, and this is the next line. Okay, and this is normal line. This angle is equal to this angle, the total angle. This one. ಕಾಣಿಸ್ತದಲ್ಲ diagram ಅಲ್ಲಿ? Okay, ಇದು. So ನನಗೆ ಬೇಕು ಇವಾಗ ಈ ಮೇಲಿನ ಈ angle ಮಾತ್ರ ಬೇಕಾಗಿದೆ. I know this one R1, so this total is I. If I subtract it by R1, I will get this remaining angle. Now I can write this angle as I minus R1. This total is I. ಇದನ್ನು ಏನು ಮಾಡಬೇಕಾ R1 ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕಾ ನನಗೆ ಈ ಆಂಗಲ್ ಬಂದು ಬಿಡ್ತದಲ್ಲ ಓಕೆ ಈ ಆಂಗಲ್ ಏನು ಬರೀತೀನಿ ಇವಾಗ Q is equal to the total I minus R1 okay so I'll write this as delta is equal to I minus R1 plus in the same way how you write QRE see here this is like this straight line and this is one more straight line okay so if it is E and the total larger angle is E this total angle is E so E total angle ಅಲ್ಲಿ 8 part ಇದಾವ E part ಮತ್ತೆ E part R2 ಅದ so total large angle ಅಲ್ಲಿ R2 ನಾನು ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಲ್ಲ ನನಗೆ ಸಿಗ್ತದ so this angle is equal to total angle E minus R2 I'll write E minus R2 is it clear so ಇದು ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿರ್ತದ ನೀವು ತಿಳ್ಕೊಬೇಕಾ ಈ ಟೋಟಲ್ ಇಲ್ಲಿ I ಇತ್ತು ಅಲ್ಲಿ R1 ತೆಗೆದ್ಬಿಟ್ಟ ನನಗೆ ಇಷ್ಟೇ ಬಂತು ಇಷ್ಟೇ ಓಕೆ ಟೋಟಲ್ I minus R1 I got this is total E ನಲ್ಲಿ R2 ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡೋಣ ಇಷ್ಟು ಉಳಿತಾ ನನಗೆ ಓಕೆ ರೈಟ್ then simplification next step the delta as it is delta equal to I minus R1 plus E minus R2 take the positive terms one side I'll write that I plus E and next minus R1 minus R2 okay I plus E minus R1 minus R2 and the next step delta is equal to I plus E minus R1 plus R2 what I did I have taken the negative outside this will be R1 plus R2 okay I call this is the equation number ಎಷ್ಟಾಗಿದೆಲ್ಲ 3 ಆಗಿದಲ್ಲ ಇದು fourth equation this is equation number 4 okay if the deviation is the minimum value if the deviation attains the minimum value which we call as angle of minimum deviation so it's simply deviation if it arrive the minimum value we call as a minimum deviation okay so now delta is equal to dm if so then what the value of I is equal to E we know this concept if it is a minimum deviation angle of incidence is equal to angle of emergence and R1 equal to R2 and I said this is simply R. We know if it is a minimum deviation case, then angle of incidence emergence angle are equal and R1 R2 are also equal. Okay, substitute this value in the equation 4 and the equation 3. Okay, I write then equation 3 become equation 3. What is the equation 3? This one. A is equal to R1 plus R2. Both are equal. I say A equal to R plus R. R1 R2 are same okay A equal to R plus R so again aita A is equal to R plus R means A is equal to 2R then R equal to A by 2 then R equal to A by 2 is it okay then one more equation 4 becomes equation 4 this one if this is a condition minimum condition what about the equation 4 so instead of delta what I have write instead of delta I have write dm equal sign I plus E but both are equal I write I plus I so E value is also I minus ಏನಾಗಿದೆ R1 plus R2 so instead of writing R1 plus R2 so I will write this is A so why I have written R1 plus R2 as a A because I know from the equation 3 so I plus I or you can write one more step here this is delta is equal to I plus E minus A why I written this directly because R1 plus R2 is a A we know it from the equation 3 so this is equation number 4 okay and next so dm plus A. I take minus this side. A is equal to 2I. Okay. Then I is equal to A plus dm divided by 2. So this is the angle of incidence. Is it right? Okay. Next one. By the Snell's law. What is Snell's law? So refracted rays of second element with respect to the first is equal to sine of I divided by sine of R. Sine of I divided by sine of R. Next, n of 2 1 is equal to, what's the value of I here? A plus dm by 2. And what's the R? This is A by 2. Okay, I substitute this value. Sine of A plus dm by 2 divided by sine of R value. R value is A by 2. Okay, and usually N2 means Ri of prism. We take it as N, and N1 is Ri of surrounding. I call this is air medium. For air medium, this is 1. Now, so N of 2 1 is equal to N2 by N1 is equal to N. Now the equation is N is equal to sine of A plus N of 2 1 बदलागी N बदला. Okay, so sine of A plus dm by 2 whole divided by sine of A by 2. Okay, so this is the final expression. So this is the Prism formula, and if you add this step, so you will get 5 marks. Is it clear? Okay, this is thin formula. Prism formula. This is Ri of prism, sine of angle of prism, angle of minimum deviation divided by 2. Sine of angle of prism divided by 2. Okay, so ಇಲ್ಲಿ ತನಕ ನೀವು ಮಾಡಿದ್ರೆ ನಿಮಗೆ 5 marks derivation ಮುಗೀತಾ. Next ಇನ್ನೊಂದು ಪಾಯಿಂಟ್ ಬರ್ತದೆ thin prism. So thin prism. Okay, so some prisms are called as thin prisms. So when you say the prism is thin, so there is a condition. That is, if the angle of prism, if the angle of prism is less than or equal to 10 degree. If the angle of prism is less or equal to 10 degree, then we call that prism as a thin prism. Hoda? So the angle made by the two refracting surface is the angle of prism. So this angle ಏನಾದರೂ equal to 10 degree ಇತ್ತು ಅಥವಾ 10 degree ಗಿಂತ ಕಡಿಮೆ ಇತ್ತು ಆಗ ಪ್ರಿಸಮ್ ಗೆ ಏನು ಕರೀತೀವಿ ನಾವು thin prism. Okay, and if the angle is very small, if the angles are very small, if A is small, then the dm will be small. Okay, if so the final expression of the prism formula n is equal to is the sine function of A plus dm by 2. Here we can neglect the trigonometric functions. As a result, this is ಈ sin function ಬಿಟ್ಬಿಡ್ತೇನೆ. ಇವಾಗ ಏನಾಯ್ತಾ A plus dm divided by 2. A plus dm divided by 2 whole divided by sin of A by 2 ಇತ್ತು. ಇದೇನಾಗ್ತದೆ ಇವಾಗ simply A by 2. ಹೌದಾ? So sin functions ಅನ್ನು ಯಾಕೆ ಬಿಟ್ವಿ ನಾವು? Because we are taking a very thin prism whose angle is lesser than the 10 degree or equal to 10 degree. It is very small. Okay, and then cross multiplication. This is A divided by 2 into n equal to A plus dm divided by 2 as it is. This two cancel. ಏನು ಉಳಿತಪ್ಪ ಇಲ್ಲಿ A into n. Next A plus dm. Take this A this side. This is A into n minus A is equal to dm. Okay, so what's the dm? Dm is angle of minimum deviation. So dm equal to what I can write? I can take the A out, which is common. It is an. This is A, and the remaining term is n minus 1. N minus 1. So there is a one more important result, and this formula is applicable only for the thin prism. Okay, so the minimum deviation in a thin prism is equal to A into n minus 1. Okay, note these points.